Welcome to the walkthrough of Advent of Code 2022, Day 5 in C++. So today's problem is about moving crates between stacks. And the tricky part in this puzzle, for me at least, was parsing this input. So what the problem you're going to solve is that you get these stacks. In this example, you have 3 stacks. So Z and N here is stack 1, M, C, D is stack 2, and P is stack 3. And then you have entries of moves. So you move one crate from stack 2 to stack 1. So that's the D on top of N. Then you move 3 crates from stack 1 to stack 3. So then you had the D, the N, and the Z goes on top here, and so on and so forth. So my solution looks like this in C++. So I first parse the input into a data model. I'm going to look at that in a little while. And then I loop through the moves in the data model. And for each move, I execute this loop here, count number of times. So the data model I have, I put the counter how many crates to move in the 0 index. And the first index is from what stack I'm going to move it. So I take the top from that stack. We have a logging output, and then I put it. No, I pop it from that stack, and then I push it, the crate, to the stack index at move index 2. Okay, so a little convoluted there, but let's look at the parse function, because that's where all the nitty-gritty things actually happen. That's the hard part of this problem, I think. So I defined a model like this. So the model is a pair, where the first part are the stacks and the second one are the moves. And that corresponds to the stacks here and the moves here. So first let's look at the parse function. So I just read lines, and then I make a state machine. So I have a state, I start at state 0, and state 0 is reading the stack definition, and state 1 down here is reading the moves. So reading the stack entries, I check if the red line is an empty line. Then I know we have read all the entries for the stacks. And the first thing I do is I turn the top entry, which will be this one, into indices. And I pop that line. And then I loop through the indices and a logging entry, and then I put an empty stack on that index. So index 1 gets an empty stack, 2, 3, 4, 5, and so on. Easy enough. So for any other line, if the line size isn't 0, I just read the line. I turn the line into crates using this helper function. I pop that entry, and then I loop through the indices, and I check if the crate I'm going to examine is no crate, because we can have empty spots here. So those we shouldn't push onto the stack, of course. So if it is actually a crate, some logging entry, and then I push onto the model on the stack with this index. I push push the crate with index -1. So it's a little convoluted because crates are actually a vector of characters. So those indexes goes from 0 to size -1. So these indices here, they go from 1 up to size. So I just offset that by 1. And the helper function to crates is also a bit convoluted, at least my solution. So what I do, I take this layer, which is a string, and I also take the count. And basically, I take chunks of 4 characters until there aren't any more 4 characters. So the 4 characters are the brackets and the crate, and the brackets and the crate. And it's a little bit tricky at the end here because there is no space following the last crate. So it's a little bit index trickery here so that we don't read past the end. I suppose you can clean this up, but this is what I came up with. So, and each time we find one, of course, we push that one. So then we get a vector of crates here. That was the 2 crates helper. When we come here and find the empty line and has processed the stack definitions, we go to state 1, and for each one here we turn the entry into a move. So then we are down here and turn these lines, parse them into moves, and a move is I just went for an array of 3 ints. So I just call this toMove helper, and the toMove helper simply parses the input line using C++ stream input. So I define the 3 ints I want out, and then these dummies that are strings, and then I just parse the string here. So we get a word, an int, a word, an int, a word, an int. And then I assign the result, which is this array of 3 ints and some logging output. Okay, that was the tricky part. The result is just taking the top of each stack and making a string out of it. So you take from left to right, the top from each stack, and then you get the result. So for the test data, then we get CMZ, the expected one, and for me the final result for my input data was this word, so to speak. Okay, so moving to part 2. The only difference between part 1 and part 2 is that in part 2 we can move several crates at once. So we're going to preserve the order of the count number of crates we move. So we kind of grab them at the bottom instead of taking them one by one. And the way I solved that was I introduced a little in-between stack toMove. So instead of moving it directly, I pop from the from stack and I push to the toMove, and then I go through the toMove stack and push them onto the target stack. In this way, I first reverse them and then I reverse them back, so they will end up in the target stack in the same order they were in the source stack. Nothing more to say about that. Took me unfortunately 2 hours because I got stuck on the parsing and on the figuring out how to use C++ to parse this data. So if you want to, stay tuned and watch me solve this problem. If you have, thank you for watching and see you next time. Okay, good morning YouTube. It's 0600 here in Stockholm. And here we go. Supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. Okay, so we're looking for the desired crates. Seems like, what's it called? The game of Hanoi? Okay, anyway. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure. The rearrangement procedure. Move 1 from 2 to 1, move 3 from 1 to 3, move 2 from 2 to 1. Okay, how's the big puzzle looking? Okay, so let's start with stacks and then we have a series of moves. Okay, here goes. In this example there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is at the bottom. Okay, there it is. And crate N is on the top. Yeah. Okay. Stack 2 contains 3 crates from the bottom to top. They are crates M, C, D. Finally, stack 3 contains a single crate P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, one crate is moved from stack 2 to stack 1. Move 1 from 2 to 1. Yeah, of course, you can only move the top one from the stack. In the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved one at a time, so the first crate to be moved, D, ends up below the second and third crates. In the second step, 3 crates are moved from stack 1 to stack. Yeah, the whole stack is moved there. Okay, then both crates are moved from stack 2 to stack 1. Again, because crates are moved one at a time, the crate C ends up below crate M. Ah, okay. Yeah, of course. Finally, one crate is moved from stack 1 to stack 2. The elf just need to know which crate will end up on top of each stack. In this example, the top crates are C, M, and Z in stack 3. So you should combine these together and give the elves the message CMZ. After the rearrangement procedure completes, what crates end up on top of each stack? Okay, so we have 2 problems. One problem is to parse this input, which might be easy enough. Yeah, okay. Okay, so now I had a cup of coffee and breakfast, and now I can tackle this. So let's see, here's an idea. We put these entry lines into a stack. So, and this line here with the indices will be at the top of the stack because that's the last one we push. Then we loop through the indices here, and we map these indices to a stack. Then we pop each of these lines, turn them into crates, and then push these crates onto the stacks mapping. So let's see how that's going to work out. So how does my solution now work on the real data? Fingers crossed. Yes. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crate mover 9000, it's a crate mover 9001. The crate mover 9001 is notable for many new and exciting features. Air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to stack 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order. Part 2 loose on the final data. Fingers crossed. Yes. Okay. I got a little bit lost there on the parsing of the stack. That was unfortunate, but it's a remaining problem. I can't get a good grip on how to parse efficiently in C++. I get confused with streams, iterators, and so on. So I have to work on that. But anywho, there you have it. If you have Thank you for watching and see you tomorrow.
If you like my videos, feel free to do nothing.
Just grab a cup of coffee
and enjoy.